Hello everyone. This lecture video includes detailed solutions to 3-word problems, which are all related to distance, rate or speed, and time concepts. Let's look at the questions in detail. Question number 1 is a situation where a plane made a trip from place A to B and back. On the way to B, the plane flew 1,000 km per hour, and on the return trip, it went 1,200 km per hour. How long did the trip take to place B if the returning trip took 4 hours? First, the keynote here when you are solving distance, rate, speed, time questions are to try to visualize or draw the situation. Second note is drawing the distance, speed, time formula triangle. Let's draw the situation first. When a plane traveled to place B, it had a speed of 1,000 km per hour and traveling hour was not given. So we can set that as x hours. However, on the way back, the plane had a speed of 1,200 km per hour and it took 4 hours. And we can draw the formula triangle, which was the second note. As you could have realized while drawing the situation, the speed and time for those trips are different, but they have the same distance traveled. Therefore, the product of speed and time for both trips must be the same. So now we can calculate the distance traveled from A to B, which is product of 1,000 km per hour times x hour, that is same as the distance travel for the returning trip, which is 12 km per hour times 4 hour. So the first product is the distance from A to B, and the second product is the distance from B to A, which are the same. And we can solve for x in this case by subtracting 1,000 to the both sides of the equation, which will give you 1,200 times 4 over 1,000, that is 4.8 hours. Now, let's look at the second question. A train A left Vancouver and traveled towards Toronto. 2 hours later, a train B left traveling at 220 km per hour. After traveling for 6 hours, the train B finally caught up the train A. What was the train A average speed? Just like the question number 1, we first need to draw the situation and also the formula triangle. So let's draw the situation first. Train A travels from Vancouver, and say the point on the right, C, is the place when train A is caught up by train B. The speed of the train A was unknown, which we'll write it as x km per hour, and time travel for train A is 2 hours plus 6 hours, which is 8 hours in total. The speed for train A is x km per hour, and time is 2 hours plus 6 hours. In total, that's 8 hours. Train B also traveled from Vancouver to point C after 2 hours later than the train A with a speed of 220 km per hour, and time it took was 6 hours to get point C. Also, it is safe to have the formula triangle written down at a side. Again, you could have realized while we are drawing the situation here, the travel distance for train A and B are the same between Vancouver to point C. To put that into an equation, we can say the product of speed and time for train A must be equals to the product of speed and time for train B. Therefore, x kilometer per hour times 8 hours must be same as 220 km per hour times 6 hours. And we can solve for x by dividing 8 to the both side of the equation. That'll give you 165 km per hour. Jumping to the last question today, car A left downtown and drove east. Car B left 2 hours later from downtown driving 30 km per hour faster than the car A, east direction, the same direction. And after 1.5 hours, car B caught up the car A. Then what was the car A average speed? This question is similar to the previous question, question number 2. However, the speed of car is not directly given to you, but it gives you the relationship between the two car speeds. Again, step by step, let's visualize the situation first. Car A drove from downtown to east direction with a known speed of x km per hour. Speed is x km per hour, and total drive time for car A is 2 hours plus 1.5 hours, which is 3.5 hours, until the car B caught up to point C. Also, car B traveled from downtown with speed of 30 km per hour faster than car A, so the speed of car B would be x plus 30 km per hour, and the time it takes to get point C is 1.5 hours. Same rules apply here, that the products of speed and time for car A and car B are the same, as the travel distance are the same. Therefore, we can write the equation of x kilometer per hour times 3.5 hours is equals to x plus 30 kilometer per hour times 1.5 hours. Again, you can solve for x, that 3.5x is equals to x plus 30 times 1.5. You need to distribute that 1.5 to both of the term inside the parenthesis. So you will have 3.5x equals 1.5x plus 45. Then 2x equals to 45 and x equals to 22.5 km per hour. Thank you very much for watching the video and good luck on studying.